I will be discussing day 57, problem 1. This problem is a mixture of the Ferris wheel problem that we encountered in quarter 1 and the guard tower problem that we encountered recently in quarter 4. The problem features a merry-go-round that turns 40 degrees per second, and we have to find P of t, so the distance of Andy, who's on the merry-go-round, his shadow, which hits the wall, the point at which it hits the wall, and N, which is the point closest to the merry-go-round on the wall. So in order to do this problem, we must find an equation first using trigonometry to find P of t. We take the sine of theta, and because it's 40 degrees per second, theta equals 40t, where t is in seconds. So we take sine of 40t equals P of t, which is the opposite, over 24, which is the hypotenuse. And that comes out to P over t equals 24 times sine 40t. And that will help us with both parts of the problem. So let's get into part 1. In part 1, we're asked to find what the average rate of A after the shadow passes N. In order to do that, we must find, because it's the average, we must find a point that's closest to 0. So you could choose 0.1 or 0.01, but the closest it is to 0 and the less it is, the most accurate it's going to be. So I picked 0.01. So after putting 0.01 in for t in our formula, we get 0.168. And after putting 0 in for t in our formula, we get 0. As you can see here, there is P over t is 0 because the shadow of A on the wall and N are the same points. And now we have to find the average rate, or the speed. So speed equals distance over time. So we have to take the distance, which is P of 0.01 minus P of 0, over the time in seconds, which is 0.01 seconds minus 0 seconds. And that comes out to be 16.755. So because P over T is in feet, and because T is in seconds, then the average rate of A after the point on the shadow passes N is 16.755 feet per second. For the second part of the problem, unlike the first part of the problem, we are given the value of P over T, which is 12. So we plug in 12 into our original formula, and we're trying to find T and solve for T. And T is the time it took for P over T to equal 12. After isolating T, we get T equals 0.75, or T equals 15 over 4. There are two answers, because if we're using the inverse of sine on 1 over 2, there's going to be two different answers in the first and second quadrant, which gives us these two answers. So I'm going to be using 0.75 as the time. We plug that back into our original formula for T, and we solve for what P over T is, which is 12, as we already knew that. And we have to pick a point in time that's closest to 0.75 to find the average rate. So I picked 0.751, which is 0.001 more than 0.75. And after plugging this time value back into our formula, we get 12.015. Just as the first problem, we have to find the average rate by using the speed formula. So the distance, which is P of 0.751 minus P of 0.75, over the time, which is 0.751 seconds minus 0.75 seconds, which is the average rate when P over T equals 12. Thank you.